So one of the techniques we have available to us when working with quadratics is called completing the square. Two primary reasons we're going to use completing the square will be to put an equation into vertex form to graph it, and also to solve. So the steps I have here are actually for solving a quadratic by completing the square. And for this, I am assuming that we have an equation that is in ax squared plus bx plus c form. Okay? So we're going to take the constant, the c, and move it to the right-hand side of an equal sign when we have it set equal to 0. We're going to take 1/2 of our b term by dividing by 2. We're going to square that result. So we're going to take 1/2 of b and then we're going to square it. We're going to add that to both sides of my equation. The reason that we're doing that is so that the left-hand side of my equation is going to be a perfect square. Right? Once I have a perfect square trinomial, I can rewrite that as x plus or minus a value all squared. We're going to add it to both sides of our equation so that it remains balanced, so we haven't effectively changed anything. We're going to factor the left, we're going to simplify the right, and then we're going to take the square root of both sides and we're going to solve the equation. So let's go ahead, let's do this on an example. So here we have x squared plus 16x minus 9. So the first thing I want to do, I want to take this c term and I'm going to move it to the right-hand side of my equation. So when I do that, I'm going to have x squared plus 16x plus, and I'm going to put a blank here, equals 9 plus a blank. Now, I put that plus a blank on both sides, partly because I don't want to forget that whatever I do to the left, I also have to do on the right-hand side. So I'm going to take 1/2 of my b term, which is, in this case, 16. 16 divided by 2 is going to give us 8, and I'm going to square it. And I'm going to add that to both sides of my equation. So on the left, what I've done now is I've just created a perfect square trinomial. I have x plus 8 all squared. If I FOIL that out, I'm actually going to get x squared plus 16x and, well, plus 64, which is 8 squared. On the right, we're going to have 9 plus 64 squared, which is going to give us 73. Now at this point, what I can do, and I'll come back to this step in a minute, but what I can do from here, I can take the square root of both sides. When I take the square root of both sides, I get x plus 8 on the left equals plus or minus the square root of 73. Now 73 doesn't have any perfect square factors, so I can't simplify it. So here I can simply subtract the 8 over, and I'm going to get x equals negative 8 plus or minus the square root of 73. These would be my two solutions. If I punch them into my graphing calculator, negative 8 plus root 73 and negative 8 minus root 73, I'm going to get two answers, and those are my two x-intercepts or my two solutions. Now if I came back to this second line I have written here, if instead of solving this, if I had written this with the 73 on the same side, right, I could write this as y equals x plus 8 quantity squared, and if I subtract that 73 over, I get this equation. Okay, so I'm assuming I didn't have it set equal to 0. This would give me a parabola with a vertex at negative 8, negative 73. So if I wanted to go and graph this, I know the a value here is 1. It's not written, but it is 1. And I have a vertex at negative 8, negative 73. And I could go with our techniques for graph shifting that we've already seen, and I could go ahead and graph this equation.